The use of manipulatives in math is common in primary grades to help students develop crucial foundational understanding of math concepts. However, their use diminishes as students move into upper elementary, middle school, and high school. And yet at these higher grade levels, their value is just as important in helping our concrete and kinesthetic learners build learning bridges that help them grasp the more abstract mathematical concepts that we're teaching. Let's take a look at how we can incorporate these powerful learning tools in our own classrooms. Let's look at all the rich math concepts and skills we can teach with a Tangram. I begin by putting my students in teams of 4. Each student has an elbow partner with whom they share a Tangram, and they have their face partners who have their own Tangram. I try to make sure they have 2 different colors of Tangrams so that we can keep the parts straight when it's time to clean up. But this pairing of the manipulatives forces my students to work cooperatively and promotes dialogue. And that dialogue is very important in helping students develop meaning in the mathematics and also to help students who might be struggling with the math. But there's another very important reason I want dialogue, and we'll talk about that at the end of this video. I begin by giving each pair of students the standard 7-piece Tangram kit and asking them to try to make a square. This may take a while with some students and they may need some guidance, but eventually my students will find out how to make a square out of the 7 pieces. Next, I pull aside the 2 large isosceles right triangles, and I ask them what part of the tangram I pulled aside, and they tell me 1/2. Then I isolate one of those large isosceles right triangles, and I ask them what value it has. They realize it's half of the half, and they say it's 1/4, which is correct. Then their task is to find values for all the other pieces in a similar way, and I let them go to work. They may notice that the medium isosceles right triangle covers exactly half of the larger one. That means that it's 1/2 of 1/4, or it has a value of 1/8. Likewise, the 2 smaller congruent triangles will perfectly cover the medium triangle. So each of those smallest triangles is 1/2 of the 1/8, or 1/16. They will then begin to manipulate these and find out that you can also rearrange those 2 smaller triangles to make the square. So the square is 2/16. It is 1/8, just like the medium triangle. And by another rearrangement, those 2 little triangles can be made into the parallelogram, which is also 2/16, or 1/8. One of the powerful things about teaching this way is it allows students of diverse learning styles to have access points. For example, I've had students that borrowed one of the medium triangles from their face partners and set it opposite their own medium triangle, as you see here. That shows that 2 triangles fill the upper right quadrant, and 2 would fill the lower right, 2 would fill the lower left, and 2 more in the upper left. So 8 of those go into the whole tangram, so that triangle is 1/8. Some students have also noticed that the 2 smaller triangles and the square will cover the largest triangle. And that square can then be substituted for 2 more small triangles by sharing with our face partners. So the small triangle is 1/4 of the 1/4. It's 1/16. There are so many different ways that students can approach this. Once they found the fractional values, and we've talked about how they did that, I asked them to go back and find the decimal equivalencies. Now, many students know that 1/4 is 25/100 or 0.25. Since the medium triangle is half of that, they can cut that in half. And if they can't cut 25/100 in half, they can annex a 0 and cut 250 thousandths in half to get 125 thousandths. Then I asked them to find the percent equivalencies as well. So students are making these interconnections among the common fraction, the decimal fraction, and the percent fraction representations. I've also asked students to find the area in square inches. The entire tangram measures 4 inches square, so it's 16 square inches. The large triangle has a base of 4 and a height of 2. The formula is base times height cut in half on a triangle, so 4 times 2 is 8, cut in half is 4 square inches. But wait, that's 4 square inches out of 16. That's 1/4. It's another confirmation that they've done their math correctly. It's like a self-assessment. The medium triangle has a base of 2 and a height of 2. 2 times 2 is 4. Cut it in half. It's 2 square inches. 2 out of 16 is 1/8. As you can see, there are so many different things that we can do with a math manipulative that really help these students. But by far, the most powerful thing you'll notice is this. Whether the students are working on area in square inches, finding side lengths with the Pythagorean theorem, using common fraction, decimal fraction, or percent fraction representations, they're speaking in algebra the entire time. You'll hear your students say things like, 2B's makes an A, 2C's makes a B, and 2C's makes a D, so B is equal to D. And your students will talk algebra throughout this entire activity. So try this with your students, and you'll find that the power of manipulatives really accelerates the learning in your own classroom.